In the dead of night in western India, remote camera traps recently captured something incredibly rare. This is the caracal, a highly elusive wildcat, instantly recognizable by its black, tufted ears. Researchers attached a radio collar to one of these cats in January 2026 to track its movements. They observed an animal perfectly engineered for its environment, capable of leaping vertically into the air to snatch birds right out of mid-flight. Finding an 18-kilogram apex predator in this specific location is highly improbable. Summer temperatures here regularly hit 50 degrees Celsius, and surface water is virtually non-existent. The survival of the caracal proves that this environment is not a dead zone. It is a highly active, hidden ecosystem operating right on the absolute edge of what biology can endure. This map illustrates the Thar Desert ecoregion. It spans a massive 264,000 square kilometers across the northwestern part of the Indian subcontinent, sitting squarely on the border between India and Pakistan. This chart compares the population density of global deserts. While extreme arid regions are typically empty, the Thar supports an average of 83 people per square kilometer, making it the most densely populated desert on Earth. It also draws tremendous volumes of wildlife. Flocks of Mongolian demoiselle cranes migrate thousands of kilometers to winter in the exact same scrubland, shared by herds of native blackbuck antelope. How does a landscape entirely devoid of a constant water source manage to sustain millions of humans alongside a dense concentration of wildlife? The sheer volume of life here is the direct result of an ancient geological reset, one that forced the extreme adaptation we see today. Dig directly beneath the crescent-shaped Barchan sand dunes of the modern Thar, and you will find Jurassic-era marine fossils. Millions of years ago, this entire region was the floor of a shallow ocean, eventually swallowed by waves of sand. As tectonic plates collided, the resulting pressure pushed up both the Himalayas and the Aravalli mountain range. These new, towering peaks physically blocked monsoon winds from raining over the western plains. This map highlights the region's ancient hydrography. The dotted orange lines represent the Ghaggar-Hakra river system. Deprived of glacial meltwater and monsoon rains, these massive waterways slowly dried up and faded into the earth. Looking at these excavated brick foundations, we see the immediate archaeological aftermath. The Indus Valley civilization had prospered along those riverbanks. When the surface water vanished, their sprawling urban centers were abandoned to the encroaching desert. The vanishing rivers subjected the entire region to a brutal filtration process. The only organisms left behind were those capable of extreme biological engineering. Take the saw-scaled viper. It moves across the boiling ground using a technique called sidewinding. By throwing its body laterally, it ensures only 2 points of its scales touch the scorching sand at any given moment, minimizing heat absorption. Above ground, local swift species bypass the hostile surface almost entirely. They catch insects, sleep, and even mate while in continuous flight, dodging the perils of the desert floor. But the true anchor of this ecosystem is botanical, the cadre tree. This diagram illustrates the cadre's survival tactic. Dropping seeds onto rock-hard, highly mineralized soil is a death sentence. Instead, the tree spreads a massive taproot horizontally underground and pushes up new shoots to create a sprawling, interconnected clone forest. Humans engineered an almost identical solution. This circular, stone-walled structure is a traditional tanka. Paired with agricultural embankments known as kadins, these systems capture brief seasonal rains and store the water underground, completely protected from solar evaporation. Every surviving entity in the Thar, from human architects to the roots of a tree, operates under a strict mandate of total resource efficiency. The pinnacle of this desert architecture is Jaisalmer Fort. Built in the 12th century from local golden sandstone, it remains the world's oldest living fort. Its massive walls were dry-stacked, constructed entirely without modern cement. Today, however, those ancient walls are cracking. The foundations are actively failing, threatening the thousands of residents living inside. This cross-section shows exactly why. Modern, unplanned piped water was introduced to the fort without proper drainage. The sandstone, engineered by nature to absorb what little moisture it touches, absorbs the leaking water, swells, and cracks under its own pressure. The greatest threat facing this ancient desert infrastructure is an artificial abundance of water. This vulnerability brings us back to the caracal. Because the margins of this desert are so easily disrupted, the Rajasthan government launched a dedicated caracal project in April 2026. The initiative allocates 90 lakh rupees to actively monitor and patrol 6 distinct zones, stretching all the way from the Ranthambore Tiger Reserve to the Desert National Park. The caracal's Schedule 1 protection status guarantees legal defense for the animal, but more importantly, it legally mandates the preservation of the highly specialized arid scrubland that sustains it. The Thar Desert teaches us that true resilience doesn't come from forcing modern abundance onto nature. It comes from mastering the art of adapting to its limits.